I've reset up the flame wheel for ArduCopter version 4.0.7. Basically what I did, I came in here and did the firmware install, which you can't get to right now. Then under setup, just basically follow this list down. Frame type, click here, accelerometer calibration, I did it, no big deal. Compass calibration, I did it, it seems to work fine. Radio calibration, I did it. Everything, all my switches seem to work exactly like they're supposed to. All my controls, throttle, whatever. Servo output, I'm letting the flight controller take care of most of these, so you can't really see them here. Escape calibration, did this. Now this one you better watch out for, because some people are skipping over the fact that you have to disconnect both the USB and the battery. The board has to be completely unpowered. So you click here, connect the USB and battery, put the throttle high on your RC transmitter, plug it back in. When you hear the proper tones from the ESCs, and that will vary from ESC to ESC, what you're listening for, that's controlled by the ESC manufacturer, not the flight controller manufacturer. You lower your throttle to 0. You'll then hear a sequence of beeps from the ESCs, again according to the manufacturer of the ESCs, and you're calibrated for the correct values that your RC radio puts out in PWM. Might play with this in the future just to make it spin a little less. Doesn't matter that much. Went into my flight modes and put in stabilized, auto, loiter, drift, altitude, hold, and land. Went into my fail safes. Fail safes, I noticed, is a place you can see your stick movements on the your control radio when for the first 7 channels anyway. There it is. That's 8. This would be 7. This would be 6, and then 5 is my series of switches across the top. These can be easily seen for the first 8 here, more so than in radio calibration or servo output, because they're not assigned as a pass-through or whatever here. You can't see them. Just touching on some things I've talked to people about over the past year. This comes enabled with a radio failsafe. Always return to launch. If this value is set on the radio, then it will invoke a return to launch. In other words, if you lose your radio. I don't want to fly with that right now. I don't want to fly with a ground control station failsafe either. I will fly with a low battery failsafe, but I'm going to set that to 15 volts. Don't have to do anything in here. Don't have an ADSB sensor yet. Optional hardware. Don't really have anything to do there. I am using these radios, but they're configured out of the box. There's nothing to change on them to make the telemetry radio work. I kind of see that my battery monitor is working right, so I assume all this is correct. Later on, when I do a calibration of the current meter on the flight controller, I will change parameters in here. I will do the compass motor calibration probably in the future. I do have some OSD to configure, but that's in a different place from this one. That's about it. That's basically how you set up a Ardu platform. Myself, I usually play in this full perimeter list here, and I will go through this one by one, and there's over 1,000 different lines here now. If we look at it real quick, of the perimeter list is, I just want to make this a text that can be seen. If we look here right now, there are 1,185 lines of configuration perimeters and flight perimeters in this file. This is the text file that you write out in Mission Planner. Like here, AHRS orientation, comma, 0. This is each perimeter in the full perimeter list, comma, and the value for that perimeter. It's a simple text file. That's all there is to this. There's a few places in here I do want to change, but I'm not going to sit here and go through 1,100 perimeters in this. And when I turn on some more OSD screens, there'll be more perimeters. For instance, this area has to do with acro trainer and what angles, pitch, yaw, roll that it will allow. This is an ADSB enable on the airborne airplane alarm. It's a system used in civilian aircraft where they transmit their position, and ADSB, you can have a receiver and you can receive their position. This platform will even avoid them. It'll detect what direction they're coming from, what radian they're traveling on, and it will calculate a movement 90 degrees to that to get away from them. I'm going to play with that later. Let's see, I can come down here and see that this is the minimum satellites. I like 7 instead of 6, just my personal preference. This orientation on the flight controller is good. So again, I like rudder arming, the 2 here. Again, I'm not going to go through, I am going to go through myself every perimeter on this list and set them for values that I know I want. Here's auto tune section and what axis you're going to be tuning on. I only tune 1 at a time. This is currently set up to do 3. I'm not going to do that. Battery capacity, I'm running a 6,200 milliamp hour battery. Just little changes like this is all I'm going to do. Battery low, 15 volts, like that. Battery monitors for other batteries, 2, 3, and 4. I'm not monitoring monitors up to 9 batteries. I'm not doing that. Camera areas, CAN bus. This is where I had to make sure the protocol was 1, and it was, but I did have to enable the CAN P1 driver. I set this to a 1 from a 0, thus enabling it instead of it being disabled by default, and that made my CAN bus work. I did those in the configuration when I was doing the compass and stuff in the setup tab. Circle radius, compass auto rotate. The compass, in my humble opinion, is rotated clockwise 90 degrees. But somehow this compass orientation 0 with the compass calibration I did seems to be keeping it right. It's not 90 degrees off, so I'm going to leave it like that for a while. Put more battery. Oops. Let's see. Most of this other stuff I won't be changing at this time. I do want to go down in return to home altitude area. This is where I had to set the GPS type to 9 so it would be on a UAV CAN bus. This is the INS landing altitude, landing speed. Not using that. Okay, I will use my OSD channel. OSD channel. OSD channel. It was fail safes. OSD. That should be this one. Okay. I just checked that on my radio, so that's 8. So I'll go back down to OSD. Oops. Go to OSD channel. So that will be 8. RC channel 8. Yep. I'm not going to use a disarm. May have to change this a little bit. Anyway, and these are all the OSD settings. For OSD1, OSD2 is not enabled. I want OSD2 enabled, so I'll put a 2 there. And I want OSD3 enabled, but not 4. I only have a 3 position switch. I really can't get to 4 easily. Going to have to make a big correction here. So you just saw I put OSD2. Instead of putting a 1 in to enable it, I put a 2 in for OSD2 and put a 3 in for OSD3. But luckily, if we look at the parameter list on the screen now, OSD2_ENABLE, enable, you can see the software was forgiving of me putting a 2 in this value. As it says here, 0 to disable. Looks like it's any other number to enable. I made a mistake there. And also on OSD3 enable, I put in 3 for it. And you can see here on OSD3 enable, the software forgave me for that mistake and set it to a 1 for me, knowing that I didn't really want a 3 there. I wanted a 1. So it's pretty nice that the software saved my butt there, but I did make a mistake there. Got away with it, but nonetheless a mistake. Moving on down. All of this has to do with the RC channels, 16 of them. Range, relay, and your RC mapping relays. Rangefinder area. 3 rangefinders, 4 rangefinders, Jiminy Cricket, 5 rangefinders, 6, 7 rangefinders. Come on, people. 8. I haven't been in this version. Rangefinder 9 type, rangefinder A, so we're in Hex or some other, so that's 10. Whew, 10 rangefinders. Okay, return to launch altitude of 1,500 centimeters. And what was that set to? 1,500? Turn to launch altitude 1,500 centimeters. $49 feet. I don't like that. I want it to be 25 feet. So 762 centimeters. 762. Okay, now we have a bunch of serial ports. Then we go into servo functions. 416 servos. Or so. This has to do with some modes of flight. Super simple. Train following enabled. Enable train data. Yeah, I'm going to let that stay as a 1. That may hold me up on the ground station frequently if it can't get the terrain data off the internet. But here's your terrain follow option. I'll be playing with that later. I think I usually set this differently, the waypoint yaw behavior, but we can come back to this. This is not going to affect flight. Some of these waypoint speeds I probably would want to slow down. So I'm going to click write parameters to save all the changes I just made. Parameters successfully saved. Save to file. There's my current Flamewheel ArduCopter parameters. I'm ready to fly it again. This past Friday was 10 weeks since I fell and hit my head. I've been driving for 2 weeks. I've been getting a strong urge to fly. I feel like I can handle emergency situation now without being kind of slowed down. So I am recovering. I'm pretty good shape, I think. So sometime in the next 2 weeks, I will fly this again. I probably still should give myself a little time past when I think I'm capable to fly again from a head injury. We'll play it by ear. Probably see a video pop up of me flying tomorrow going, yeah, I was fine. I don't know when it will be for sure. But this is basically the ArduCopter setup of the Flamewheel again. I did change ArduCopter versions, so I did start out with a clean slate again on the parameters and such. So I'm going to have to go back through the flights I already had gone through, where do a manual flight and then position hold and a return to launch and stuff. That's why I set the return to launch at 25 feet. I don't want it getting too high in the air over anything, and work myself back up. It won't take me but 2 or 3 flights to work myself back up to the auto tune level. And we'll finish out the configuration in ArduCopter, and then, as you know, I have the INav figured out and set up, and can dump that in about 3 minutes. Just a few seconds, 5 or 10 seconds over 3 minutes. I can convert this from ArduCopter to INav. I do have to change a connector on the GPS physically when I do that, but I've got all that figured out. So real quick, we'll take a look at the copter itself and some of these hardware changes. So this is the physical setup on the flame wheel for the ArduCopter. The compass GPS module is connected CAN bus in the center port of the M8Q CAN compass GPS module. When I run it on INav, I have to take this second connector and hook it into the right port and run it as a serial module on INav. But I can run it CAN bus on ArduCopter. So that's the only physical change I have to make when jumping between the platforms. And I'm going to have to tie up these cables so that they can't get out into a prop. So that's not quite where it will finally be. But other than that, there is no physical difference between ArduCopter and an INav copter flight setup. I did make just a few more changes real quick. Some of them very important. In RC channel 9, RC channel 9 option right here, I set it to 4, which is return to home, return to launch. I think everybody's going to agree with me that that's pretty important. And then I made sure my mode switches on my radio worked, and the return to launch on the radio worked. So only thing I'm using on the radio is the control sticks, these 2 switches, and these 6 switches across through here for modes. That's it. This is for OSD screens. OSD2, OSD3, OSD1. It switches through 3 OSD screens, and this is return to launch. Return to home. And then the loiter mode. Stabilized mode. Which, if we look up on the screen at the same time I change these, we'll see this one is landing. See, it changes on the screen to agree. This one is drift. Screen agrees. Altitude hold. Altitude hold. Auto mode. Auto. The screen agrees with all of these. Loiter mode. Stabilized mode. And then return to home. So I did set those up in addition and tested them. I will assign some of these other switches to the auto tune when I get ready for it, but this is basics for first flights, and it's ready. All right, I guess the next videos will be of it in some kind of flight, perhaps a crash, you never know. Thank you so much.